Well, good afternoon, sports fans, and welcome to Dunks Railway and Airfield. This afternoon, I'm going to try to show you an HO speedometer, or an HO model railway or railroad locomotive train speedometer. And we're going to do it on a breadboard first, and then eventually transfer it to a circuit board or a printed circuit board. And hopefully that'll come today. But let's just start with this. Now, this here is the schematic that we're going to work with, or a basic start anyhow. And we are going to use Arduino. And when we get all that done, it'll be going on to a printed circuit board that looks something like that. And with any kind of luck, it'll work. So, anyway, let's get started. We will be using a Arduino Nano. Here's our printed board. We'll need some jumpers. Now this here is an Arduino Nano clone. And that's what we're going to use today. We'll also be using an Arduino sketch, which you can find on the Arduino website. Now, mostly there was another modeler out there, Spence, I believe his name was. Can't remember his first name off the top of my head, but I have to look it up. And a few other people that I found on YouTube and other websites that I'm using some of their ideas to come up with this one. So if you follow me along and you like it, you can build your own, or you can contact me and I'll build it for you. And we can go from there. But to start out with, let's plug in our Nano. Into the breadboard. That's going to take a bit, it looks like. Looks like we might have to make a couple adjustments on the pins. having a bit of issue here, I see. I guess we're going to do the There we go. Just have to hold my mouse right. Okay. Now we'll also be using, which is different, different than what other people use, is these for sensors. Now, I tried using just the plain Jane sensors without the internal resistors built in. What I like mostly about these is that you can adjust the distance of the sensitivity, and that works out quite nicely. Now, I've got the sketch loaded on my computer already, so when we're done I'll be able to just download it onto the Arduino. And I've set it up to run the sensors roughly at 1 foot right now. But for the time being, we will leave them like this. We're just building a and there is the number reader. Okay, and when it's all said and done, that should come up at miles per hour. Now, for you, those that are interested, I will be using the ZIF socket to hold the Arduino, and I'm going to be placing these plugs on the circuit board which is our female. I'll be wiring the male on here also with a longer wire to go to wherever you need it to be. So I'm going to have the display and the sensor to plug into this board. And this way you can put the board, I have the board set up already on my layout, which I will show you later. But this way you can put the board where you want, the sensors where you want, and the display where you want, and in whatever you want. If you want me to build your whole setup here, I'll just put together the circuitry, and what parts you need, you will have to decide where you want to put it and how you want to display it. But anyway, that's enough of that for now. Let's get started. So, according to the schematic, we need power. So, let's get some power going first. So we know that by the Arduino, that 5-volt power is 1, 2, 3, 4 pins in on the right hand side. So 1, 2, 3, 4 pins. So that's positive. Okay, now what that does is make sure that that particular side of my breadboard is powered positively. Now, the ground is 1, 2 in on this side, so that's here. And we will put, okay, that energizes that side of the board. Next is we are going to power the other side of the board, just for the sake of ease. And since we are here now, it's easiest to do it as we go. Now these jumpers and things you can get from Amazon or pretty much any website. Same as the breadboards. The best is to buy a kit. And the kit will have like an Arduino kit. And it comes with the breadboard and the jumpers and a few other odds and sods. And it gives you a rough teaching on how to use the kit and everything that comes in it. And so I would suggest to go that route, especially if you've never worked with anything like this. If you have and do know how to C+ program and work with the rest of that type of equipment and programming, you don't need to do that. But as a refresher, yeah, good plan. Anyway, back to this. Okay, now we are energized. Well, we won't be until we plug in, but jumper-wise, we are energized. Now, the next thing will be to put the sensors in play. Now, what we're going to do is I'm going to put in one sensor on the board, and I think I'll make the other one floating so that we can get them 1/4 apart and give you a rough idea on the actual speed. But for the time being, let's set these up. So on these, you got 4 pins. Now you have plus, digital, analog, and ground. Now with the Arduino, we will be using the digital circuitry today. So let's start with that. So it'll be D, according to the schematic, sorry, it's either D4 or D5. Okay, so to start out with, we will use D4. Now the other one will be D5. Now, as you can see with this schematic, okay, that the way it was designed to work is that these are for a different kind of sensor, which, oh, here we go, looks something like that. Well, for the life of me, I could not get these to work. I tried different methods, different wiring schematic, different everything. I just could not get them to work. And you use these using the resistors. And in respect that it's a good idea and so forth, but to hide them in the track, this is all good when you're building, the system and incorporating this technology into your layout brand new, no issues. But if you're already set up and running, I recommend that it's easier to go this way, and you can build a fancy little cover or box to hide these in if you want. Lay them on the side of the track, and they will work that way, which I will show you shortly. Now, we need power for these units. And the other thing is, make sure that you don't cross your pluses and minuses. Now, granted, they're not that expensive of a unit, but they're also not the easiest to come by either. So if you want to, just make sure you get everything correct when you're hooking all this up. But all right, we're getting there. Slow but sure, we are getting there. Okay, just to confirm. Signal to digital, check. 5-volt power, positive. Check. Negative 5-volt power, check. This one is correct. Digital signal, check. Ground, 5 volt power. Check. Ground, 5 volt power, positive. Check. Okay. That end of this is all good. Now the signal and power for the display. Now we'll be using A4 and A5 for that, and I will try doing it this way so it'll be a little easier to see. So we need you need to look at your pins. 5 volt power, 5 volt power, ground, SCL, and SDL. Oh, sorry, I got that reversed. SCL, SDL. Okay, those are the two signals. So, sorry about that. With the amyloidosis, it's difficult every now and then. So, now to continue on. Plus power, plus power. Minus power, minus power. Now, let's say 4, which is SDL, okay, which is this one. Okay, that's the number 3. Or counting, or number 2, depending on which way you count. And next, see if we can find the jumper that's the right length. And the 5 Now there's the bird's nest. Now I got this rigged up for roughly a foot apart, and that's what we are. And next, I'm going to have to stop the damn camera because I have to load the sketch onto the Arduino. So, a pause for the cause. And then I will show you the next part. Okay, we're back. Now we have it loaded, everything lit up. On the first go, I was impressed. And so here we go. So picture like the sensor of the train going by, triggers the first sensor, then the second sensor, 26.05 miles an hour would be the approximate speed of that particular model HO train. Now my understanding is we can set the sketch up so that you can go to larger trains. HO scale and N scale I believe are the same. And you can, like, it's just a matter of plugging some numbers into the sketch. And because the math required to make the calculation is built into the sketch. So, therefore, it should work. In that theory, anyhow. Let's do it again. Zoom, zoom. 4410. That's pretty cool. Now, it takes roughly 30 seconds for it to reset itself. Now, the thinking there is that it's going to take approximately 30 seconds for the train, a long train, to get through the sensors before having to re-trigger. And as you can see, it's done. So then the train will go round the track again, come through, trigger it again, and away you go. Now, as of yet, I have not figured out how to set the sensors up so that you can get it coming back the other way. I think what would work would be a series of relays. I've tried 2 sets of sensors, but the problem being it does work, sort of, but you got to figure out a way to turn off the other sensors so the train go back the other way without triggering those ones. Because what will happen is that, like for instance, this will always be the start sensor and the stop sensor. So when this goes to 0 again, go back the other way, go like this, nothing happens. And now that'll start the sensor again. So now it won't trigger again until it comes all the way around and triggers it that way. And so you're going to get like, 0.3 of a mile an hour or some damn thing. So that's not exactly what you want. So what I'm working on, and I haven't quite figured it out totally electronically, is to put a relay system in so that when this one here is triggered, and then this one's triggered, you get this. But this one triggers the relay to turn over to the other circuit, or the other set of sensors. And then what would happen is that set of sensors would work like these ones, and so forth. The hard part with that is I can get the trigger once, but it won't come back, because I haven't figured out how to do that yet. And I'm sure it's probably as simple as rewriting the sketch a little bit, but my genius isn't that great. So I'm going to have to get a hold of someone that knows what they're doing, and they can figure it out. But anyway, for the time being, that's it for Dunks Railway and Bearfield. And I will be back after with this particular bird's nest put onto a printed circuit board. And as of yet, also, I have not found anybody that will print my boards out for me that is reasonable. But anyway, so if anybody's up there that knows someone that can print my boards out and put in the traces and all that stuff, so make my life easier, because right now I'm wiring each circuit board like I'm using like a generic board, right? So I'm wiring all my traces by hand. So it takes forever. You know, and then of course I'm using an enameled wire, which is okay. Like it helps hide it and looks better. But any mistake and we could end up with a short. But anyhow, that's it for today. I will be back. Okay, we're back. And I have the circuit board. And the best I could do as far as doing tracing goes. Now I tried to use enameled wire to do some tracing, and it worked for a bit, and then it became a little more difficult, and then it just didn't do what I wanted. So I went back to a fully proper insulated wire, and hooked up these. I don't know if you can see all that or not. And let's just see how we made out. So I'm using a ZIF socket to for the nano, because when you install this, you may need to, over a period of time, redo the programming, or change your mind on the programming and move a sensor or something along that line, and then you'll need to adjust it. Like for instance, installing the sensors. Right now I have it set up for, I believe it's 14 inches. So this particular one, I'm not sure exactly where I'm going with it. I got a pretty good idea. But until I complete my table, I won't know the measurement of the sensor. But at least we can check and see if this one works. So let's start with installing the digital readout. Now I made these connections up. And they will work quite nicely, I think. Now I set it up for a dual display, this particular setup. I believe that's the best way to do this. So that you can, I have it set up so that you can have one display at your control panel and the other display where you will be running the train across. This particular one will be going where I have a long bridge. And we can go from there. Boy, yawning, sorry. Now here's the sensor. On the back of these, you may notice, there's a blue potentiometer. Resistance pot, whatever you want to call it. Now what that does is actually measures the distance that it triggers. Like the distance, how far this sensor is. Because you want to make sure that at least it's recording or sensing. Now, to make these cables up, the wire is nothing special. I got that from our partners in China. That's the cheapest way to go if you don't mind waiting the 50 or 60 days it takes for shipping. And same as the sensors. And actually the whole spiel came from China. And these are special crimpers for this type, this flat, and this Mulex type. Now, I got that stuff in China too because it's a lot cheaper. And I was in no hurry. Okay. Now these particular ones, I've got it powered via USB. So we will do that. And let's turn it on and see what happens. Well, looky here. We lit up. Can you see that? Alright. Now I got these labeled as stop and start. This is the start over here. There you go, 40.35 miles an hour. Pretty good, eh? Now these ones here I have it set up for a 30-second reset. Now, my trains aren't quite that long, but at least I know that if I do put on a longer set, that it's not gonna run into one another. So that's for sure. So we'll do that again. Train goes by, and there's 64.41. Okay, I'm happy with that. Extremely happy. It's working. Now the next thing I'm going to do shut this off and disconnect. And turn it over. Now I bought a product called liquid electric tape. So what I'm going to do is paint the bottom of the circuit board to protect it and let it dry. And while that's drying, I will take you downstairs to the layout and you can see how the one I have already set up operates. And it might give you an idea what you might want to do. Now, like I said before, I'll be more than happy to make you a board and sensors if you wish. All you have to do is let me know. And I'm thinking for a cost of about $85 US. Anyway, that's it for right now. I'll be back shortly with my layout. Okay, just a quick drop in. So I'll show you what I did. Got that all painted up. As you can see, some wires cover, some don't. But what it'll do is protect the solder joints from corroding and the wires from being moved around and breaking. That's all I can do for the moment. I'm going to try to find a circuit board manufacturer that will print my board for me, but I'm having a real problem with that. Can't seem to find anybody. Not that it's cost effective anyway. Everybody seems to be like super expensive. So if there's anybody out there that wants to print my circuit board for me, hey, let me know. Or if anybody knows anybody that prints circuit boards, let me know. Anyway, we'll be moving downstairs shortly. Hey, welcome to Dunks Railway and Airfield. And here we are. Part of it anyhow. And there's the setup I have for the sensor. Now, you just got to turn the system on so you can have a look and see how it works. Okay, it looks like we have an error on the bottom track. Top one seems to be doing okay. Let me do a reset on the bottom track. Okay, as you can see, I have that turned on. And we'll start up a train. Okay. As you can see, that's approximately 44.47 miles per hour. It will take 30 seconds to reset. And then it'll redo it again. And there it is. Okay, now I'll put the train on the upper track and see if we can get them both going. Oh, we have another error. Sensor came on too soon. There we go. 116.5 miles an hour. I don't know if that's correct or not, but the thing is moving pretty fast. Alright, there you go, and now you have it. That's it for the front throwaway and the airfield. Have a great day. Okay, we are back. So, here's the circuit board. Complete. And here's the painted part with the liquid black electrical tape. And that will keep all the solder joints sealed from outside air from corroding and so forth. So let's see how it all looks. So let's put this together. Okay, we're ready to energize. And here we go. Okay, well, oh, a broken wire. see how that works, but we have one lid up. Yeah. Let it reset. And there we go again. So as you can see, it does work fine. Alright, YouTube fans, that is it for this episode of building an HO speedometer for my